Look up at the night sky, and you might assume we have the basics of the cosmos figured out. We can map spiral galaxies, track the remnants of supernovas, and even photograph the shadows of black holes. Our mathematical models paint a picture of a universe that behaves exactly as we expect it to. That confidence took a serious hit in 2019. Radio astronomer Anna Kopinska was reviewing new telescope data when she spotted a massive, glowing blob of radio emissions that defied all categorization. Next to the image, she scribbled a single note: WTF. This is an odd radio circle, or ORC. It is a colossal, ghostly ring of energy floating in the deepest realms of intergalactic space. It didn't match the profile of a dying star or a standard galactic collision. The true shock came when researchers calculated its size. Spanning 2 million light-years across, a single ORC dwarfs our entire Milky Way by a factor of 10 to 20. Better technological lenses are uncovering a layer of shadow mechanics, violent, unimaginably large forces that actively break our established rules of astrophysics. These massive structures remained hidden until we built the right lens. The Australian Square Kilometre Array Pathfinder, or ASCAP, sits in the arid outback. By sweeping massive swaths of the sky at once, it cuts through the cosmic static to reveal faint, diffuse objects that earlier telescopes completely missed. This diagram shows the 3 leading hypotheses for what creates an ORC. We might be looking at the radiating shockwave of 2 merging supermassive black holes. Or we could be looking straight down the barrel of a cone-shaped plasma jet firing from an active galaxy. The third option is a massive, expanding spherical bubble blown outward by millions of stars being born simultaneously. Because we are finding drastically different variations, like the cloverleaf ORC, we are likely witnessing the chaotic aftermaths of multiple unimaginable cosmic forces that break our understanding of scale. The rules of time are just as fragile as the rules of scale. 18,000 light-years away, an impossible cosmic metronome named GPM J1839-10 has been hitting Earth with a steady radio pulse every 22 minutes, stretching all the way back to archival data from 1988. This chart maps the spin period and energy of pulsars. As these stars spin, they emit sweeping radio beams. But as they lose momentum, they slow down and drop into this thick horizontal band at the bottom, known as Death Valley. At this point, the star goes dark. A normal pulsar spins multiple times a second. GPM takes 1,318 seconds to complete a rotation. It sits completely submerged in Death Valley, yet we still detect its sweeping radio beams. Temporary events like starquakes on highly magnetic neutron stars can release bursts of energy, but they fade within a few years. They cannot explain a beacon that has been flashing steadily for over 3 decades. This ticking phantom represents an entirely unmapped class of celestial object, proving our mathematical models for neutron stars are incomplete. In an ancient universe teeming with habitable planets, we hear zero radio chatter from other civilizations. Physicist Enrico Fermi famously asked, "Where is everyone?" The answer might be a matter of perspective. Humanity invented the radio in the 1890s, so our radio bubble, the sphere of signals leaked into space, is only 130 light-years wide. In a galaxy 100,000 light-years across, we have barely whispered into the room. We may have heard a whisper back. In 1977, the Big Ear telescope detected a 72-second-long radio pulse, 30 times more powerful than the cosmic background noise. It behaved exactly like a localized artificial signal. It became legendary as the wow signal, but it has never been heard from again. Fleeting anomalies like the wow signal prove that probability is skewed by our primitive listening windows. The universe might be loud, but we are essentially deaf. Monumental cosmic phenomena can hide right next door if we are looking through the wrong lens. In 2011, the Alpha Magnetic Spectrometer on the International Space Station detected a massive, unexplained deluge of high-energy antimatter particles raining down on our atmosphere. The true culprit is Geminga, a collapsed pulsar plowing through the Milky Way at 210 kilometers per second. Its intense magnetic field accelerates antimatter particles to near the speed of light, firing them directly at our planet. Traditional radio telescopes couldn't see it because of a trick of geometry. A pulsar's radio jets fire out from its poles, while gamma rays blast out from its equator. Geminga's radio jets miss our planet entirely, while its equator points perfectly at Earth. Geminga's invisible halo spans 40 times the size of the full moon in gamma radiation. It proves that terrifying cosmic engines can hide in plain sight if our perspective is limited. Space is a roaring, chaotic engine room filled with phenomena that outright ignore the physical laws we spent centuries writing. For most of history, our naked eyes only caught a microscopic sliver of true reality. We judged the universe by a fraction of its total light. The fact our textbooks are constantly proven wrong is an invitation to keep innovating, building new lenses, and embracing the unknown.